centuries, actually, one of the richest and most productive countries, not only in Europe, but the entire world. And it is still is today, as both in terms of overall GDP and GDP per capita. But if you take a glance at it, you'll see that that production occurs here, Ile-de-France. It is the metro area, the urban area of around Paris, and in the southern Rhone Valley and the Mediterranean coast. The rest of the country, you don't see many lights, and lights are perhaps the best proxy for where people live, and even more for where production occurs, because firms will have lights, basically, just put it in a simple fashion. That's true for France, but that's especially true for Spain and the Iberian Peninsula overall, meaning that you have a huge chunk of people and production here in the exact center of the peninsula around Madrid, and then everything else is just on the coast. I mean, it's like Madrid is surrounded by a large desert where almost nothing happens. Of course, this is oversimplifying it, but that's not too far from reality. That is like a fractal phenomenon, meaning that you can see that if you take a look at the world map, if you take a look at the continental map, and if you take a look at a country map or a regional map, it always works. It's always like this. People tend to agglomerate, and the economy tends to agglomerate even more. Then what's the problem? The problem is what you see in the map on the right, that we tend to study these through the lens of these, meaning through the lens of national borders, or if we are very lucky, through the lens of regional or perhaps provincial borders. That is, we're putting everything in predetermined units that are necessary to simplify the number of observations that go into our analysis and the number of computations that allow us to produce something through our analysis. But this is a huge problem because it's what we call, you guys probably know it even better than me, the modifiable area unit problem, which has some, not variations really, but some different instances that it can present to it. The first one is that the results you obtain depend a lot on the shape and on the size of geographic units, because that same region could be rebuilt. France, again, is a clear example because its regions, it's a very centrist country. The government decides almost everything. The préfecture, the arrondissement, etc. The local governments don't matter much, even historically after the French Revolution. So they always change. They're always reorganizing them. Sometimes they have the Grand Région, the large regions. Sometimes they work through département, the small provincial units, etc. And they produce always different results because it depends what cities or towns or rural parts of the country you are engulfing within the predetermined unit. And that will produce, by definition and by construction, very different results. But then you also have another problem, actually two problems, two aspects of one problem. You don't know the internal distribution, meaning that you don't know whether, let's not work always with France, which could be boring. Let's shift to Italy, the country where I live in, Lombardia. You don't know whether this region that you see here in the northern part of the country, whether everything is occurring in the center, in Milan, or whether it is nicely distributed all around. You cannot know that. You only know the numbers for the region. You know the unemployment rate or the number of unemployed people in the region. You know how much production is occurring in the region, but you don't know where it is happening. And that could have very, very, very meaningful differences depending on its geographical distribution. Connecting to this problem, you have edge effects, meaning that sometimes borders are actually based on physical borders. Spain and France, you have the Pyrenees chain mountains that are about 3,000 meters high separating them. The same is true for France and Italy, or even more for Italy and Switzerland or Austria. You have 4,000, almost 5,000 meter high mountains separating them. So, of course, not much production is occurring on the top of those of the Alps, of those really high mountains. But it's not always like that, especially between different regions, but also between different countries. Belgium, Netherlands, and Luxembourg, the so-called Benelux, you don't have any borders. You could just drive, and people would mostly speak the same language. You wouldn't even recognize that you're entering another country, because sometimes you have, the road signs. They're even covered by trees or by something else. So it happened to me once. I was just driving when I'm going to get into Luxembourg, and then I realized that I was already in Luxembourg. And that also happens between Belgium and France, etc. So there are no physical barriers. So if you use predetermined borders, actually you don't know. You don't know. You're pretending that when you get through the border, everything goes back to zero. Nothing is remaining. Everything is ending. This doesn't work because you cannot analyze areas like this. You're losing many information. So that's why distance measures were coined, because people were tired of using those predetermined units and just trying to study the unemployment rate in Nebraska against the unemployment rate in bordering South Dakota. They wanted to know the relationship between different observations. Also, please in mind, I'm an economist, so I have this bias of always thinking through economical lenses, and that's why I try to get other degrees in order to not to stay focused on one thing only, which sounds also boring to me, and it limits your ability to observe the world. This could also work and actually have been more implemented, perhaps, in other fields. They were created to study economics. But for the problems we'll see in a minute, they haven't been really used, and that's why we try to handle them, to find a solution to that. Whereas they have been decently used in fields such as diverse as forestry or botanics, natural studies, because when you're studying a forest, the traditional thing to do was to use parcels of the forest, pieces, homogeneous pieces of the land. You took, I don't know, a square kilometer sized chunks of the forest, and you counted how many trees were there, their average health status, etc. Distance measures enable you to analyze the forest through the trees, not through predetermined by human chunks of land. And that's really useful. And that's why in forestry, actually, they use distance measures more than we do in economics. Of course, this is also because forest is a lot more homogeneous. You only need to count the trees and to sign which ones are ill, sick, or healthy. So it's easier. And that's why it has been more used in that field. So I won't bother you with explaining all the distance measures, also because most of you, I think, are better qualified than me, because it might be your very field. So I will only describe the one we have decided to use, and that is Marconi and Pugh XM, as Jonse anticipated in the presentation. This is, in my opinion, at least, the most accurate and reliable function that we could use. Please mind, this is a cumulative function, because you might also have density functions. And actually, Marconi and Pugh themselves also developed a different version of M, which is lowercase m rather than uppercase m. And that is a density measure, meaning it doesn't strictly measure, it estimates the probability of finding a neighbor, a target neighbor, at a specific distance. we are more interested in those cumulative functions such as uppercase M, this one you're seeing now, uh, because they do not estimate, they measure exactly the probability finding a target neighbor, let's say, as in our research, a, a firm belonging to a specific industry. That is a target neighbor, as opposed to any neighbor, meaning a firm working in any other industry. They measure the probability of finding those target neighbors, those you are interested in, within a certain distance, up to a certain range, let's say 10 miles or 15 kilometers, say, compare to that same ratio, to the same probability, without accounting for any distance. Meaning, are you more likely to find a textile firm within 15 kilometers from any other textile firm than you are to find a textile firm overall in the area? If your answer is yes to this question, you are looking at an agglomeration. If your answer is not, you're either looking at a let's say random distribution, or perhaps even a dispersion phenomenon. So here you see the formula. The first part is what we might call a local reference, a local benchmark, meaning that the upper part of this left component of the equation basically is measuring how many target neighbors, remember, other firms in our case that belong to your same industry, to the industry you're computing M for. But if we were thinking about forestry again, that could be you're trying to measure the agglomeration level of pine trees, say. The upper part of the left component would count how many pine trees you are finding within R, let's say 10 kilometers, from any other pine tree. So how likely are they to be close to each other? Then you need to weight that against the lower part of the left component, which tells you how many trees in general or firms in general you're finding within that selected range. So what's the probability of finding a pine tree or a textile firm within 15 kilometers of another pine tree or textile firm, as compared to the probability of finding any tree or any firm within 15 kilometers? But that wouldn't tell us everything. Many distance measures just stopped here. But then you have a problem, because in this case, you might not know what's the distribution, actually not the distribution, let's say the weight of that industry in the entire economy. So you also need to know how many pine trees there are overall compared to any tree in the entire forest, or how many textile firms are in the entire economy in, say, Italy or Australia compared to any firm in the country. And that would be our global benchmark or our global reference. When you put them all together, you obtain M, that is the agglomeration index. A number is a natural number. 1 would mean random distribution, 0 would be extreme dispersion, infinite would mean extreme agglomeration. So, but it's a number. You obtain that number for your range R, for your industry of choice or your kind of tree of choice. I'm using the antithetical example of trees just because I started with that, but you could measure everything. I mean, you could measure, I believe a linguist could use this to study differences in languages, because they could I mean, we will get into a far difficult discourse. Just this is my opinion. It could be used for anything that has a geographical component in its distribution, where geography matters, and geography matters mostly for everything. So let's get into what we have done with this ham. First, our data set is a register that was organized by the Italian National Institute for Statistics, provides data for every firm since 1996. That is almost 30 years now. And the nice thing is that you have many side informations, meaning you don't only know the number of employees and the exact 5 digit, here we have Ateco, I don't know, probably you use the ISIC codification for industries. Basically, you are able to discern firms that produce, let's say, even you're also able to distinguish farms that produce watermelons by watering them, or from farms that produce watermelons without even watering them. I mean, it's a really deep level of differentiation between what these firms and farms produce. This information is not only available for every firm, but even for every single plant, meaning that we are distinguishing the commercial, the trade office of a firm from the production plant, from the administrative office, from the registered office, from the legal seat, etc. So you know exactly where the workers are and what they are doing in that place. Meaning that if you're dealing with I don't know, a car producing firm, you could be able to distinguish those employees that do not actually produce cars. They are not manufacturer workers, but they are selling the cars on behalf of the firm. And so you will assign them to another industry, which is not car production, but which would be sales, car sales. It's a very, very nice differentiation. Let alone the last part now, I'll explain later for the matrix distances. So our work is this. Basically, we started by computing M, the index, for every 3-digit Ateco industry in Sardinia. 3-digit means that basically you're dividing your economy in 250 different industries. Okay, so it's a nice level of detail. Hotels will be differentiated from camping grounds. Bars will be differentiated from restaurants. It's a nice level of detail. More would be too much, less would be too few, probably. So we computed them for every 3-digit Ateco industry in 2007, before the Great Recession, and 2012, after somehow the Great Recession, which in Italy lasted a little bit longer, but it was the most acute phase, let's say, before a rebound into the crisis. Okay, this is what we done first. And before going there, I will show you a map. Since you are geographers and students, scholars of geography, you'll certainly be more interested in maps than in my verbal resoundings. So this is one of the many things that this index could tell you. I will show you just 2 random industries, an agglomerated one and a dispersed one. On the left, you see hotels. Please keep in mind, every green small circle you see is an observation, meaning there is a hotel. In some cases, they are just opposed one on top of each other, because there may be many hotels in the same place, so you would have to enlarge the map to see where they are exactly. This is really interesting, because when I show this to people who work in politics or in economics in Sardinia, for a moment they are stuck. Say, no, why? Costa Smeralda, the Emerald Coast on the northeast, where Berlusconi and Bill Gates, Paul Allen, even Putin, where everybody wants the money, owns a villa there, goes there every summer. how can it be less of an agglomeration of hotels compared to other places in the island? But that's true, because since you have all that tourism there, you don't only have hotels, you also have many other activities. You have the bars servicing the tourists, you have the camping grounds, you have also the artisans and the commercial activities and some production scattered around there. Whereas in other places, such as the south, the very south of the island, the tip that points towards Africa, that is far closer to Africa than to Italy. So just go figure. Nothing else is happening. I mean, you only have hotels, and that's why they're extremely agglomerated there. Because if there is an activity there, there is a hotel. And so this index allows you to discern that phenomenon, which is real concentration, real agglomeration, from the mere fact that you might have many hotels in the capital, in Cagliari, where you have everything of everything. I mean, you have barbershops, you have oil companies, you have everything. So, I mean, certainly you have hotels. It's a major urban area. So that is not a concentration. A concentration is where you have a majority of hotels compared to any other activity that happens there. And so this is nice because nobody has ever thought so far of hotels as such a big important phenomenon in the southern tip of Sardinia. I mean, somebody certainly have, but not as much as in the northeastern part. So that tells you something that many other common indices do not tell you, especially the ones that are not distance measures and work through predetermined units. Then on the right, you have a dispersion phenomenon, and that is cleaning activities, of course. I mean, you will certainly need cleaning activities not to be close to each other, but as far from each other as possible, because there is no, economies of scale. I mean, they are not influenced by the seasonal tourists going there. I mean, somehow they could be, but it's a lot less than hotels for sure. And so what you see here is that the agglomerating chunks of land, they are not really agglomerating. I mean, it's just they coincide with the largest urban areas. In the south here, you have Cagliari, the capital. And of course, I mean, you will have many cleaning activities than in some other places because it's just the largest city. Indeed, the second most agglomerated area is the second largest urban area, Sassari. Then you have an interesting phenomenon again in the northeast. Why? Because that would be the third most agglomerated, the third metro area in Sardinia, but you see less agglomeration than in far smaller places. Why? Because you have the tourists. It's related to what you see in the other map. You have many hotels, but they are scattered all around the coast, not only in the capital, Olbia. And so the cleaning activities, in a certain sense, have an incentive not to stick close to each other around Olbia, but to go and follow the hotels on the coast. That doesn't happen in other major cities because they are not so touristic. So that's what happens. That is just to show you how it works. We're almost done. I won't bother you for much more than this, because the very focus of our presentation here is what we've done to reduce our complexity. We decided to, let's just see this. These are islands in Italy, the three largest islands. Sicily, you all know that, mafia and stuff. Sardinia, which is our island, and Elba. We chose Sardinia not only because it's our island, but because it's just as large as Sicily, but has a lot less population, but not so small as Elba, than to be biased in the production of the analysis. So we chose this to understand whether the map on the left, which are very tiny administrative units, municipalities, basically, we call them comuni, can be a decent approximation of the real thing. The map on the right, where production actually occurs. Please note the number down below. You have a reduction from 7 billion pairs to only 70,000 pairs. So if this approximation works, I mean, think about when you're working not with Sardinia, but with Australia, or think about what could be the possibility of analyzing China, for example, because if in Sardinia you have a 7 billion pairs to cross every firm with each other in order to work with distance measures, just think about how many couples, how many pairs would China or the United States or even Australia have. Just to give you a number, if you think about Italy, if we were to work with the entire country, our pairs would go up from 70,000 to 32 million as concerns municipalities. But if we were working with plant pairs, meaning coupling every firm, every plant, the numbers would go from 7 billion in Sardinia to almost 12,000 billions. So just think about the United States or China. They would be absolutely unmanageable. And that's the reason why nobody had ever used M for real life analysis. And we believe we are the first that we have used it in an entire region. The only instances I found are for small neighborhoods in Barcelona or Cali or Lyon, but they are just examples. They are comparing just two industries, whereas we're using all the 250 industries and we're working with an entire region, not just the neighborhood of one city. So basically, does the first map approximate well the second one? Yes, it does. See the correlations. Do not even pay too much attention to the first one, which is 5 kilometers. It's a very small range. I mean, agglomerations usually span more than that. They span about 10, 15 kilometers. And if you look at the 10, 15 kilometers, you see there are the real case, without any approximation is MA, correlates at about 0.99 with the approximation, meaning that the approximation pretty much tells you the exact picture, but it does it reducing the number of computations from 7 billions to 70,000, which is, I believe, wonderful. It also works with a dynamic picture because one might think, okay, it's good. It works for 2007. It works for 2012. But what if we were studying the evolution of agglomerations and dispersions through the Great Recession, for example? Would it work in measuring the change? Yes, it does. The numbers are the same. They are about 96, 99% correlation, meaning that the results are mostly the same. Just a final note, and then I leave you to any question and answers or whatever. See the last two columns, MMT and MMR. These are tentative, meaning that's our next step, because those columns tell us the approximation, the correlation with an approximation, which is not based on geodesic distance, because geodesic distance still has a problem, even within distance measures, that you might have a mountain in between, or that you might have a lake or a river. And so the distance that people actually travel to go from one firm to the other one might be very different. In Sardinia, we have a central mountain, the highest in the island, which is not inhabited, and it separates for 30 kilometers the two parts of the island. So if you see the correlation with the MMT, which is the actual travel time, how long it will take you in minutes to travel from one firm to another, and the MMR, which is road distance, how many kilometers of actual driving it takes to go from one firm to another, you see that the correlation is still very high, but is a little bit lower. But, and this will be our next research question, we believe that this might be the one that tells you the truth, not the actual measures, meaning that we believe that you lose more by using exact positions, but as crow flies distance, than you did if you approximated the positions to the center of these really tiny municipalities, but used actual road distance. So this is for the next time, guys. Here it is. Thank you very much.